We're going to review the bow tie and some inverse trig, and this is going to be a short review because we spent a lot of time on this last spring. First off, I want to go review the bow tie. Okay, if we draw a bow tie, what we're talking about is, looking at the values of the trig functions. These are, of course, all right triangles. And we have to think, which values are positive, which ones are negative. Well, it's very simple. Just think of your coordinates here. Okay, all three of those are positive on that triangle. But when we go to the one below it, obviously this one is positive, but this one is negative. Okay? But remember that all of your hypotenuses are positive. Always. Okay? Hypotenuses are always positive. This one over here is positive. And then these two values right here would be negative. Okay? So last year we spent a lot of time reviewing reference angles and all of those things. I'm not going to take tons of time to do that because we should be good with that. But what I want to do real quick is just start with a sample problem like the cosine of 240 degrees. And we're doing this without a calculator, okay, using the bow tie. So 240 degrees, we have to think, first off, which quadrant are we in? We are in the third quadrant, down here. So if I'm in the third quadrant, how do I find the reference angle? It is the value minus 180, right? That's to find the reference angle. So it's 60 degrees. Okay? Now the reason that's important is that tells me what my reference angle is in here. This is 60. Okay? And so this is, of course, a 30-60 right triangle. And then I need to label my sides appropriately, as we have learned, right? And I believe we learned that this is 1, 2, radical 3, like that. You always start opposite the side of the 30-degree angle, but I need to put in my negatives here, don't I? This is negative, this is negative. Okay? So then, what am I asked to find? I'm asked to find the cosine of which angle? It's the 60-degree angle. So cosine is adjacent over hypotenuse, all right? So the adjacent side is -1, the hypotenuse is 2, and there's my value, -1/2. A little review of how to use the bow tie, okay? Now, we probably should review how to find reference angles real quick. In the first quadrant, it's just the angle. In the second quadrant, it's 180 minus the angle. In the third quadrant, it's the angle minus 180. Okay? And then in the last quadrant, it's 360 minus the angle. One more example, just to make sure we're good on this. The sine of 315 degrees. Okay? So we ask which quadrant it's in. Of course it's in the fourth. So since I'm in the fourth, to find the reference angle, it's 360 minus 315, which is 45 degrees. Now make sure you draw the triangle so that one of the legs is on the x-axis. Your triangle has to be like this. And my 45-degree angle is right here. All right, that's the triangle we're working with. That's 45, that's 45. And yes, it is 1, 1, radical 2. But we need to label one of these as negative, this one right here. All right, and so now we are doing the sine of this angle, which is opposite over hypotenuse. So that's negative 1 over radical 2. We rationalize and we get negative radical 2 over 2. Now, the only thing that changes when we get ready to look at inverse trig is remembering where they're defined. Okay? Okay? Inverse sine and inverse tangent and their partners are only defined in the first and fourth. And last year we talked about why that's the case. It's because we have to restrict the domain or we don't have an inverse. So these two are only defined here and here. Those are the only places that we can find an answer. All right? And inverse cosine is only defined in the first and second. So it's only defined here and here. So if we are given a problem like this one, evaluate the inverse sine of negative radical 2 over 2. All right? Well, before we do this problem, one other quick review. Remember this? All scholars take calculus. That is the rule that tells me where the functions are positive. Which functions are positive where? They all are in the first quadrant, sine and its brother, tangent and its brother, cosine and its brother. Okay? That's where those functions are positive. The reason that's important is because of this right here. Okay? We're evaluating the inverse sine of negative radical 2 over 2. So since it is a negative value, it has to be in this quadrant. Inverse sine is only defined here and here. Since it's negative, it has to be in the fourth quadrant. So that is where I draw my triangle. I'm going to draw the triangle in the fourth quadrant. Okay? And since it says negative radical 2 over 2, aren't I immediately thinking a 45, 45, 90? So this is radical 2. These are 1s. This is a negative 1. All right? And so the angle then is 45 degrees, or is it? It's not 45 degrees. It's not 315 degrees. The answer is negative 45 degrees. And the reason that is, the reason we use negative 45 is because inverse sine is not defined over here. It's not defined over there. We can't go through there and say 315 degrees. It's only defined in the first and the fourth quadrants. All right? So there's a quick review for inverse trig. One last thing. What if I was asked to find the inverse cosine of negative 1/2? Well, inverse cosine is only defined in the first and second quadrants. And since it is negative, it has to be over here. My triangle does. All right? And now I'm asking, okay, how can I get 1 over 2? Well, cosine, here's my angle right here. Cosine is adjacent over hypotenuse. Okay? So if I finish my right triangle, since this is 1, this has to be 30. This one has to be 60. All right? But that is not my final answer. Cosine is defined in both the first and the second quadrants, so my answer is this one, whatever that angle is, 120 degrees. Okay? And we will stop there for today.